Hi, welcome to another video on the subject Engineering Graphics from Learn Tech Easy. In this video, we are going to discuss intersection of solids in which a horizontal triangular prism penetrates through a vertical cylinder. Let us see the problem. A cylinder 50 mm diameter and 70 mm axis length is completely penetrated by a triangular prism of 40 mm sides and 70 mm long horizontally. One rectangular face of the prism is parallel to VP and contains the axis of the cylinder. Draw projections showing the curves of intersections. In this problem, a cylinder is standing vertically by its axis perpendicular to HP and parallel to VP, and a triangular prism is positioned horizontally so that the axis of the prism is parallel to both HP and VP. One of the rectangular faces of the prism is parallel to VP and is on the axis of the vertical cylinder. The rectangular face parallel to VP is perpendicular to HP also. The triangular prism is positioned in such a way that the length is extended equally on both the sides of the axis of the cylinder. The base shape of the cylinder can be seen in the plan, while the base of the triangular prism can be seen in the side view. We will always start with the projections of vertical objects or objects which are having its axis perpendicular to HP. Draw the XY line. Below the XY line, draw a circle of radius 25 mm as plan of the cylinder. Project it above the XY line. Draw the elevation of the cylinder as a rectangle with a height of 70 mm. Draw a 45-degree line as miter line. Project the plan horizontally up to the miter line, then project vertically from the miter line. The elevation also can be projected horizontally to maintain the height in the side view. Then complete the side view. These are the three views of a cylinder standing on the ground with its axis perpendicular to the ground. Since the cylinder does not have any base corners or longer edges, divide the circle, that is the plan of the cylinder, into equal number of parts. We can divide that into 8 or 12 equal parts. In this case, we are going to divide that into 8 equal parts. Name these points as 1 to 8. Project all these points to elevation and mark it as 1 dash, 2 dash, 3 dash up to 8 dash. Project the divisional points to the side view through the miter line and mark it as 1 double dash, 2 double dash, 3 double dash up to 8 double dash. The base of the second object, that is the triangular prism, can be seen in the side view. Since the prism is passing through the midpoint of the vertical cylinder, mark the midpoint of the axis of the cylinder in the side view. Side of the triangular face is 45 mm. So take half of it, 22.5 mm on both the sides. Taking 45 mm in the compass, cut arcs from both these points. Join the intersection points of arc to complete the triangle. Name the corners of the triangle as A double dash, B double dash and C double dash. Project these points horizontally to draw its elevation. Length of the prism is 70 mm, so mark half of it on both the sides of the axis of the vertical cylinder. Mark the corresponding edges of elevation as A dash, B dash and C dash. All the edges, whether visible or invisible, can be darkened at the end. Project those points vertically up to the miter line, then horizontally to draw the plan. The elevation also can be projected to maintain the length in the plan. Name the corresponding edges of the plan as A, B, and C. Now we have to trace the points on the curve of intersection. Before that, the edges of side view and plan can be drawn dark. In the plan, the longer edge of prism A and B penetrates through the cylinder that can be drawn as hidden. Longer edge A intersects the cylinder at PA, is PA double dash in the side view, and longer edge B intersect the cylinder at PB will be PB double dash. There is no intersection point for the longer edge C. Divisional line number 2 intersects at R2 at the top and S2 at the bottom. Line 3 intersects at R3 at the top and S3 at the bottom. This can be marked as R2 double dash, R3 double dash, S2 double dash, and S3 double dash. There are corresponding points at the other side also. QA double dash, QB double dash, R4 double dash, and S4 double dash. Now, we have to mark these corresponding points in the plan. PA, QA, R2, R3, R4, PB, QB, S2, S3, and S4. Locate these points in the elevation also. PA dash, PB dash, QA dash, QB dash, R2 dash, R3 dash, R4 dash, S2 dash, S3 dash, and S4 dash. Join PA dash, R2 dash, R3 dash, R4 dash, and QA dash with a smooth curve. Similarly, join PB dash, S2 dash, S3 dash, S4 dash, and QB dash. The extended portion of the prism on both the sides of the cylinder are visible. The longer edge C dash is visible. The other two longer edges A and B are invisible inside the cylinder. The top and bottom extensions of cylinder are also dark visible lines. Thus the projections and curves of intersection of a triangular prism penetrated through a vertical cylinder are drawn.